Or 8.2 is going to be real quick, like probably the shortest section ever. 8.2 is on sample size considerations. For estimating proportions. And estimating proportions is what we did in the last section, 8.1. We were taking a sample and finding out that 43.3% supported the president with a margin of error of 2.5%. And this is based on a sample, don't write this down, this is not my notes yet. This is based on a sample of 1525. And if you increase that, you'll reduce this margin of error, because the margin of error, if you recall, is based on this formula. And therefore, you can't, if you're doing a 95% confidence interval, Z is fixed at 1.960. P hat and Q hat you don't control. It depends on how many people support the president. All you control is that N, and you can decrease the sample size, meaning getting it narrow and narrowing it down to a closer and closer, something that's pinpoint the actual percentage. If you increase that, you reduce your margin of error. So that's good. You want a smaller margin of error. The question is, suppose I want a margin of error of 1%. How I gotta change my sample size. How much do I need to change it? I need to increase it to what? So that's what we're talking about when we do sample size considerations for estimated proportions. What sample size should I be using to get my margin of error to be under 1% or something? Okay. Let me see what I got. Oh, okay, pretty much what I was just talking about. Recall margin of error. Something that you usually want to reduce is given by, for proportions at least, E is equal to Z alpha over 2 times the square root of P hat Q hat over N. Okay. Note, you don't know or control P hat and Q hat. So you can't control what % of the people support the president or don't support it. I mean, you won't know it if you're starting off trying to figure out how many people you need to survey. So you won't know P hat and Q hat. So, all right, anyway. The minimum sample, I'm just going to go straight to the formula. I missed this spelling it, hold on. The minimum sample size required to obtain a margin of error of at most, meaning you want that or less, at most E. So you're going to get it to be E or under, that's the most it can be, is, and here's the formula you're going to need, N, which will be a whole number, needs to be greater than the computation we're going to do here. Now, I'm following what the book does. It uses some non-standard notation. It's using PG, 1 minus PG. And we'll talk about what that means because that's a new thing. It is related to P hat and Q hat, but the issue is we don't know that, and we can't be plugging in things for P hat and Q hat into a formula if we don't know it, if we haven't even surveyed anyone yet. And this whole scenario is, once we decide we're going to do a survey, we need to know how many people we're going to survey. We haven't gathered any information about who's supporting the president or not yet. Anyway, it's got the Z alpha over 2, which will be based on your confidence level, so that you'll know. And the margin of error is going to go there. That you'll know. They'll tell you what margin of error they're shooting for. And you're going to square it. And that is a formula we're going to be using. I'll talk about why it's greater than. I'm going to talk about that now. N is a sample size. It needs to be a whole number. So when you do this computation, you might get a decimal. And you got to round it to a whole number for a minimum number of people to survey. And the greater than, we'll talk about that when it gets to it, but it means that whatever decimal you get, you always need it to be greater than. So this is a situation where you're not going to round up or down based on the digit to the right. You are going to always, in this particular scenario, round up to the next nearest whole number so that your n is definitely bigger than whatever you get when you do that computation. And that'll guarantee that you get a margin of error at most e. Okay, so that's going to be our formula. I'm going to copy it down here for future reference. Okay, I've got some bullet points related to that, but I don't have space, and I'm going to just erase and then continue from a blank page. Bullet point related to that. PG is the reuse of subscript of G for a guess at an unknown P hat. So again, you won't know P hat until you actually start surveying people. This whole question is how many people you should survey before you even start. You won't know P hat. PG will be a guess for that, and I put it in quotes because you're not really actually going to guess. There is a rule for it, which I'm going to go over briefly, but then don't even worry about it. The idea is you pick if you know some sort of a range for P hat, an unknown P hat, and for some reason you know that P hat happens to be between 0.2 and 0.3 for some reason. Let's say you know that. You're supposed to pick the value closest to 0.5. 0.5 for P hat means 50% support the president, 50% don't. And so if you know this, then you should pick, and graphically that means you know it's somewhere between 0.2 and 0.3. Somewhere in that range. What should you pick as a guess? You should pick the one that's closer to 0.5, so you're going to use 0.3. That'll be your guess at an unknown P hat. If you have an interval that is, let's say, P hat is between 5.2 and 6.0, that's right here to here. For some reason you know it's in that range, that interval. What should you pick? You should pick P hat is equal to 0.52 this time. Or sorry, PG is equal to 0.52. That'll be your guess. Always something closest to 0.5. Now if you have, one more time, and then don't worry, you're not going to have to do this, because I'm going to tell you what you're going to be doing. But if for some reason you know that P hat was between 0.2 and 0.7, meaning that you know somewhere between here and here, somewhere in that range, you want to pick the value that's closest to 0.5. If your interval spans 0.5, you're literally going to pick PG is equal to 0.5. And furthermore, if you don't know anything about P hat, it has to be between 0% and 100%, so it's got to be some value between 0 and 1. If that's all you know, meaning you have literally no information about it, you're going to pick PG is equal to 0.5. So for the worst case scenario for having with no information, the realistic scenario is you have no information about P hat before you start your survey. You're going to use PG is equal to 0.5. And so now forget this, because that was just a rule that they mentioned in the book. There's a mathematical basis for that, but it's not a realistic scenario. What's more realistic is having no information about P hat. And in that case, you're going to use PG is equal to 0.5. So for your homework and for the exam, whenever you apply this formula, you're going to be using 0.5 there for PG. Then you plug it into there and do 1 minus that. That's like QG. That's just 1 minus a complement. So it'll be 0.5 there and 0.5 there. You're always going to do that. I'm not worried about a scenario where you know it's in some interval and you got to choose a value that's closer to 0.5. My scenarios are always going to be no information, and you're just going to plug in 0.5 and 0.5 there. So don't stress about that. Just remember using 0.5 and 0.5. Okay, and I mentioned you always got to round up. And then I just talked about that rule about using the value closest to 0.5. So we're ready to go. A poll is to be conducted, meaning we haven't done any legwork yet. And the researchers will report and we're going to say the usual 95% CI, the standard 1-4 meter reports. That could change, and you'll have to change the Z based on that confidence level. So let's say it's 95% confidence interval. Find the minimum sample size, which is basically that formula right there. Needed to ensure the margin of error is under, and we'll do a couple of these, but the scenarios, the instructions will be the same, other than the fact that they might change the confidence level, and you got to redo a Z, get a new Z for a different confidence level. But here I'm just going to do parts A, B, and C for 95%. Here we want to keep the margin of error under 4%. Okay, so we're going to use that formula. Let me see. I'm going to follow it as exactly as written, so I'm going to use that n is greater than, and remember to always round up, but we'll get to there when we get to there. I'm going to plug in. Well, let me write the whole thing out. PG, and since we have no information, we're going to use 0.5 there. 1 minus PG, we'll use 0.5 there as well. And then the Z. The Z on top is going to be based on your confidence level. Now, if it's a weird one or you forgot your Z scores for the standard confidence intervals, you'll have to spend some time doing that. 95% in the middle. Tails are 1 minus that, divide by 2. Inverse norm of 0.025 gives me 1.960. I mentioned that's the one that all the media companies will be using because they're all doing 95%. Anyway, that'll be my Z. Capital E on the bottom is the margin of error that they're shooting for, that you want, and they specified it right here. This 4% needs to be in decimal form, so you're going to convert that to 0.04. And we're ready to go. 0.5 for PG. 1 minus 0.5 PG. Be careful, I do have people putting 0.05 and 0.05. Here's another situation where it's 50%, 50%, not 0.05, not 0.005. So watch your decimal placement there. My Z score I just figured out is 1.960. That is specific to, again, a 95% confidence interval. And my margin of error is specified right here. That's my E. 0.04, and don't forget to square it. And I would type this in or enter it into the calculator all at once. There's no weird square roots or anything. You do need parentheses around that, so because that square applies to both. Okay, and I got 600.25. So mathematically, for me to guarantee that my margin of error is going to be 4% or less, or exactly 4%, I would need to take a sample. I would need n to be 600.25 to satisfy this. Now, 600.25 is not a valid sample size. Sample size is literally surveying people, and you can't survey 600.25 of a person. So that's why we have that. It's got to be a whole number, but we don't want to round the usual way. We need, for this to be satisfied, for the margin of error to be under 4%, you need an n that is greater than this. So if you go to 600, if you round the usual way 600, you cannot guarantee you might get a margin of error like 3.9% or 3.95%. It'll be close to 4. Sorry, my bad. Let me rephrase that. If you go with 600, you might get a margin of error that's 4.1% or 4.2%. You can't guarantee it to be under 4% unless you make sure n is above this value. That's why you have to round up. So you need a minimum of 601. 601 guarantees it. It'll be under 4%, barely. 602 would be better. It would be even further under. 603 is better than that. 604, 700, 800, all of that will be good. But that's the minimum sample size. 600, you cannot guarantee that it's going to satisfy that. You cannot guarantee that it's going to keep that under 4%. It might be a little bit over. And if you're concerned about literally exactly or under 4%, no cushion there, you need at least 601 to make it greater than that. Okay, so let me put that in your notes in case you're taking notes. Always round up. I mentioned it before. I'll emphasize it here for the first time we're actually applying that rule. Okay, just do a couple more. I'm going to talk about where this comes from, but that's an optional thing, so I'll tell you when you can stop the video if you don't care. What am I doing? I'm going to erase this, but it's the same thing. I'm just going to do part B with a different margin of error. I'm going to give you some room to work. Okay, B. I want to keep, same thing, I want to keep the margin of error under 2%. Okay, let me write that formula. You don't have to write it every time. It's just, especially for notes, it's good to see it and then fill in what you know. You can be good at home as well. All right. So a lot of this is just churning out the same things over and over. PG is always 0.5 because we're always going to assume we have no information. 1 minus PG is also 0.5. Z takes some time to make sure you know what confidence level you're doing, because if they change it to 80% or 90% or 99%, that Z changes from the 1.960. But here, it's the same confidence level of 95%. Only thing different here is my margin of error. They want it now to be 2%. That's lower than 4%, so that means we should have to increase the sample size. We should have an N that's bigger than 601, much bigger, I think. We'll see. All right, anyway, that's all we're going to do is compute that. And just be careful with the decimal placement. 0.02 is 2%. We got 2401 exactly. Okay. And that's it. If it's exact, you can leave it as is. You don't have to round that situation. You can guarantee that it'll be 2% or less. Let's see. I technically said under. Don't worry about the fact that I said under. The term is at most. I just wanted to avoid using at most because people get confused by that. Anyway, 5%. And I'm not going to write it again. You have it right there. 0.5, 0.5, 1.960, 0.05 squared. Be careful, that's 0.5, that's 0.05. I got 384, okay. 384.16. There is another decimal that if you round it the usual way, it will round down to 384, but you don't want to do that. 384 may not be big enough. You need the next one up. 385 will do it. 385 guarantees your margin of error will be at most 5%. And that's it. Okay, so you can tackle the homework. It's a lot of these problems. Make sure you're rounding up at each stage to the next highest whole number. And I think I threw in a couple of extra problems related to those intervals of seeing which one contains the true value and the different news organizations that I did at the end of 8.1. So be aware, there was limited problems here, but I threw in some other thinking sort of problems related to comps and sort of proportions. All right, you can stop the video if you don't care about where this comes from, but I just want to show the derivation of this for anybody who does care. So real quick, recall what I mentioned earlier. Your margin of error was Z alpha over 2 P hat Q hat divided by N. And basically this equation comes from you just solving this. I'm not going to introduce an inequality. I could. I want my margin of error to be under whatever I get there, and then I can work it out and not have to worry about the direction of it. I won't, but ultimately I could. But I don't want to get into reciprocals and you have to switch the sign and kind of like that. But I will not. So I'm trying to solve for n. I want to rearrange this equation to get n by itself in terms of the other four quantities. I'm going to, first of all, I want to get the square root by itself. So I'm going to be dividing by the z score. And I'll get the margin of error E over the z-score is equal to the square root of p hat q hat over n. I want to get the square root. I want to get rid of the square root because I'm ultimately trying to solve for n. It's on the bottom and under the square root. I'll have to handle both those things, but let me get rid of the square root first. So I'm having e over the z-score squared now, and that's equal to p hat q hat over n. No more square root because I squared it out. Trying to get n by itself, so now it's on the bottom. I can do reciprocals. Reciprocal of both sides means, even though the square there just means e squared, z squared, they flip, I get z squared, e squared. So I can just do reciprocal this and then reciprocal the inside. So the z is now on top, which is where it will ultimately be when I finish this out. It is squared, that whole quantity squared. So reciprocals of both sides here. And I'm going to go over here. Last step, I just want to get rid of that p hat q hat. So I'm going to multiply both sides by that. And it cancels there. So I end up with n is equal to p hat q hat times z over margin of error squared. That's a relationship between n and those other four quantities based on just rearranging this, manipulating it algebraically. Now, minimum, you can work in inequality, but ultimately it would be to keep your margin of error under it. You need your sample size to be bigger than that. And also, you know your margin of error you're going for. You know the z-score based on your confidence level. You don't know that. You don't know that. And so they just do another thing where they refer to it as a PG. And I'm not going to go into why you pick a value that's closest to 0.5. 0.5 is like the worst case scenario. And using 0.5 and 0.5 there means you can guarantee that your n will keep your margin of error under that amount. So that's where that formula comes from, just manipulating that. Anyway, you're good to go. Like I said, that section was super short, and we'll do 8.3 next time. And by next time, I mean once this video uploads.